Hello everyone, this is Vani from R.M.K College of Engineering and Technology. In this video, we are going to learn about the targets required for long-term evolutions, the technologies associated with long-term evolution, and the requirements of LTE. So the main requirements of LTE are the data rate should be high for both upload and download to support the bandwidth intensive applications and services. And also LTE aims to achieve peak data rate of up to several hundred megabits per second for downlink and up to 50 Mbps for uplink. Second parameter as requirement is the spectrum efficiency. The spectrum should be utilized efficiently. So LTE employs advanced modulation techniques and MIMO to improve spectral efficiency. Similarly, the delay should be less, latency should be less. That is a third parameter. Reduced round trip time to support real-time applications like voice over IP and online gaming. And LTE targets low latency, aiming for values as low as few milliseconds. Also, LTE should be scalable. The network should be scalable to accommodate a growing number of users and devices. So, LTE networks are designed to handle a large number of simultaneous connections and to provide reliable services in high density areas. Also, it should obey interoperability property with existing cellular networks to ensure a smooth transition and coexistence with technologies like 2G, 3G, and future networks. So the LTE standards include mechanisms for backward compatibility with older technologies. That's a very important parameter. And quality of service, which should support for different service classes with varying quality of service requirement. So what LTE does is it allows operators to prioritize traffic based on service type, ensuring a better user experience for critical applications. So next is targets for LTE. We have seen what are the requirements of LTE. Now the targets are peak data rate up to 100 Mbps to 1 Gbps and wide coverage area with improved performance at cell edges where normally there is lagging in coverage that should be improved. And LTE targets better coverage and signal strength, especially in suburban and rural areas. And also the cell spectral efficiency should be enhanced per unit bandwidth to accommodate more users and services. LTE employs techniques like orthogonal frequency division multiple access for downlink and single carrier frequency division multiple access for uplink to improve spectral efficiency. Also, it should have the requirement of mobility where the seamless handovers and support for high mobility scenarios such as fast moving vehicles. So it should be taken care about, and LTE is designed to handle scenarios with varying user speeds and ensure smooth transition between one cell to another cell. Backward compatibility should be there. Reliability and security should be high. So LTE includes security features such as encryption and authentication to protect user communications. So these requirements and targets collectively contribute to the overall performance, efficiency, and user experience provided by LTE networks. So let us learn about what are the technologies used for LTE. So first technology used is OFDMA, which is orthogonal frequency division multiple access. It is used in the downlink to divide the available spectrum into multiple OFDM subcarriers, allowing simultaneous transition to multiple users. And single carrier frequency division multiple access is used in the uplink to achieve better power efficiency and reduce peak to average power ratio compared to traditional multiple access schemes. It also involves the technology multiple input, multiple output, which uses multiple antennas for both transmitter and receiver to improve data rate, spectral efficiency, and link reliability, which are very important parameters. It also applies carrier aggregation, which is simultaneous use of multiple frequency bands to increase overall data rates and enhance network capacity. followed by LTE Advanced. It is an evolution of LTE that introduces additional features to improve performance, including carrier aggregation, enhanced MIMO, and support for higher order modulation. Voice over LTE feature enable the voice calls to be carried over the LTE network, providing better call quality and allowing simultaneous voice as well as data transmission. Enhanced Multimedia Broadcast Multicast Service, defined as EMBMS, allows efficient distribution of multimedia content to multiple users simultaneously, making it suitable for services like mobile TV and video streaming. Self-optimizing networks is also one of the parameter where the technologies automate the optimization and maintenance of LTE networks, adjusting parameters dynamically to enhance performance, coverage, and resource utilization. The technologies used for LTE are also evolved packet core, which is a core network architecture for LTE, providing functions such as mobility management, session management, and packet routing. Femtocells and small cells are also the technologies used for LTE, which are low powered base stations designed to enhance coverage and capacity in specific locations such as homes, offices, or crowded urban areas. Interference management technique is one of the important technique where interference cancellation and suppression are employed to mitigate the impact of interference in dense deployments where the area is dense with the number of users. And finally, time division duplex and frequency division duplex configurations are used to cater to different spectrum allocations and deployment scenarios. So these are the requirements, targets, and technologies of LTE. Thank you.